All right, welcome back. We are going to be looking at converting and comparing rational numbers and just do a quick review of how to do that. So to start, when we are converting our decimals to fractions, we are going to use the place value of the last digit as our denominator of our fraction, or the bottom. So what I mean by that is if we have our decimal point, right, the first place value would be tenth, and then it would be hundredth, and then thousandth, and so on. So you can kind of use that as a guide as you're going through. And then our numerator, or the top of our fraction, is the value of the decimal. So looking at some examples of what we mean by that, in positive or negative, they just maintain their value. Since this is one place value behind our decimal point, this is in our tenths place. So our denominator simply becomes 10 because it's in the tenths place. And then our value of our decimal is that 4. And so our fraction would be negative 4/10. And then we always want to simplify when we can. So in this case, each of these could be divided by 2. So in the end, our answer ends up being negative 2/5. So negative 4/10 is the same as negative 2/5. On our next one, we have tenths, hundredths, thousandths. So 1,000 goes into our denominator. And then here are the value of our decimal is 345. And then because this one happens to be a mixed number because we have that 1, we just want to make sure we also include, the 1 as part of our fraction. Here we can divide both of these by 5, and I know that because 345 ends with 5 and 1,000 ends with 0. 345 divided by 5 ends up being 69. And we're going to carry over that 1, so it becomes 1, and 69 over 1,000 divided by 5 is 200. And then these two numbers are relatively prime because 69 is just divisible by, like, I think 3 and 13, which those don't go into 200. So that would be our answer. Why don't you pause the video and try the next one on your own? All right, so here we're in the hundredths place, so this is going to go over 100. Value of our decimal is 23. It is a negative, right? So we want to make sure that we include that. 23 is prime, so our answer here would be negative 23 over 100 as a fraction. All right. Now changing fractions to decimals, which I feel like is the more often used strategy. Basically what we're going to do when we change fractions to decimals is we are going to divide the numerator, which once again, remember, is the top of our fraction, by the denominator, which is the bottom of our fraction. And on a calculator, just remember that the top number always goes first when we're putting it into the calculator. So looking at what that looks like, when we have negative 3/8, once again, they're going to maintain their sign. We are simply going to take 3, our top number, divided by 8 on our calculator, and this ends up being negative 0.375. Even when it's 1 2/3, like it is on this next one, I'm not going to worry about that 1. That 1's just going to come over to our decimal, and then the decimal point's going to go there. I'm going to do 2 divided by 3, which ends up being 0.666666666 forever. And so we show that with that line that tells us that it's a repeating decimal. And just as a reminder, sometimes on calculators you will see at the end it'll go like 1.6666667, because what the calculator is doing is it's called truncating, so it's cutting that repeating decimal off, and because 0.6 would tell us to round up to 7, it changes it to a 7 at the end. In reality, that wouldn't actually happen. It's just 6 that would go on forever. If you were to do the long division, you would just keep getting 6 over and over and over again. So why don't you pause the video and try this next one on your own. So here we're just going to take 4 divided by 9. It's a negative, so we're going to make sure we bring that over, and this ends up being 0.4 repeating. And that's the most basic way to change between fractions to decimals and decimals to fractions. As you move on in math, there are going to be methods that you'll learn to maybe help change repeating decimals back into fractions and so forth, but for right now, this is the bulk of what we need to know. Now we're going to look at comparing values. So remember, when we're comparing, we are going to use those inequality symbols of less than, greater than, or equal to. So in this first one, we are going to compare the values of -1/8 to -12 hundredths. Usually what I do is I have an easier time comparing decimals and fractions, so I'm going to change my fraction to a decimal. You could definitely change your decimal to a fraction if that was easier for you. So I'm going to take 1 divided by 8, and I know that that ends up being 0.125. And then I'm going to go ahead and add a 0 behind so they're equal place values. So now I have 125 thousandths versus 120 thousandths. Normally, the 125 thousandths would be our greater value, but since we are dealing with those negatives, right, this one is more negative than this value, so this would be further to the left on the number line, making it a smaller value. So -1/8 is less than -12 hundredths. One of the other things that you'll start to see are what are called compound inequalities, where you'll actually see multiple inequality signs within the same problem. So what we're going to do here is we are going to arrange our 3 values in order from least to greatest or greatest to least. So I'm going to go ahead and make them all 3 digits. And I'm going to look. So 200 would normally be our smallest, but because they're negative, that's going to be our greatest. And then 250 would normally be our biggest, but because they're all negative, this would be our smallest. So -25 hundredths is less than -223 thousandths, which is less than -2 tenths. Or we could have also written it as -2 tenths is greater than -223 thousandths, which is greater than -25 hundredths. Either one of those is technically correct, although typically you'll usually see it written least to greatest with those less than signs. So that's just something to keep in mind. So, things to remember for ourselves. Remember that it's often helpful to use that absolute value to help compare values. Thinking about, is it more negative? And then that means it is a smaller value. Also remember that inequalities are always going to open to the greater value. Okay? And it does help to convert to one form as you are comparing. Not always, but sometimes, especially when the values are close, it does help to convert them all to one form.